Yes, good afternoon to all of you, our followers, our students. I want to welcome you today again for our lesson as usual. Teacher Kakuli is my name, and we are looking at applied maths, A level. We started on jointed roads last lesson, that was Monday, and we looked at the numbers you are looking at on the screen right now. We looked at those numbers. I would like to request the producer to go to the exercise page. The exercise page. Yes, homework, there. Yeah, I left those numbers for my dear students. I left those numbers for you to try out. I would like us to showcase one number among those so that you can cross-check your answers. And we shall later add on with several other numbers. This topic is very short, and I expect that today we should be able to close it so that you are free to go and look for more numbers in other textbooks and try out. I want to begin by once again sending humble greetings to my mom and my family and all the students that go to King's College Budo. I send you my greetings. Enjoy the lesson. We are going to work through that number one. Those who attended this lesson last week, you already have the questions, and probably you tried them out. So we are going to try out number one, and then we shall be giving you the next number after we are done with number one. Just a bit of reminder, I told you that here, with this concept, we need to look at two cases. One, when we have not separated the diagram or the jointed rods, and the second case when we have separated the jointed rods and we introduce new forces that we call X and Y. Now, we can draw this diagram like this. It is still the same diagram, but I am going to alternate it. This point where the rods join is B. I have switched it to have my A here and have my C here. That implies that my AB, which is 3A, is this side, and my BC, which is 4A, is this side. And then my SC, which is the joining, is 5A. I will go ahead to indicate forces acting, and we shall have a reaction here. We can call it RA. We shall have a reaction here. This is before separation. We can call it RC. We are told in the question that the two uniform rods AB, which is 3A, and BC, which is 4A, have weights W and 2W. If they say uniform, it implies that the weight acts halfway. The weight acts halfway. So we shall have a weight for AB, which is W, and a weight for BC, which is 2W. Before separation, these are the only forces acting, and therefore, if we indicate the force, because SC, they are telling you, is a rod. The rods rest with A and C on a rough horizontal surface. So since this surface is rough, that's why they're asking us to find mu. We shall let a force act here and a force act here. This force will later be looked at as the frictional force. I will go ahead to introduce angles. I will call this angle alpha and this angle beta. So that is my sketch diagram now, or our sketch diagram. Now, I will go ahead first find the sine of alpha. I will find the cos of alpha. I will find the sine of beta, I'll find the cos of beta, and I will eventually find the tan of alpha, because we need to use them. Sine is opposite. Since this is a right angle triangle, sine alpha will be 4a over 5a, so it will be 4 over 5. Cos alpha will be 3 over 5. And sine beta, this is beta, the opposite side is this. So this would be 3 over 5. And cos beta is definitely going to be 4 over 5. In other words, the sine of alpha is equal to the cos of beta, and the cos of alpha is equal to the sine of beta. Eventually, tan of alpha being equal to the sine of alpha over the cos of alpha will give us sine alpha over cos of alpha. This will be 4 over 5 times the reciprocal, which will give us 4 over 3. We will need these quantities, and that is why I am showing you the quantities over here. And now, we proceed to look for the reaction. We proceed to look for the reactions. I will take moments at A, and I will start from here. Taking moments at A, I expect that from our previous lesson, we all know what a moment of a force is. If we are taking moments here, this W will be clockwise, this 2W will be clockwise, and the R will be anti-clockwise. So I'll start with RC. The perpendicular distance for RC is 5A. So we shall have RC times 5A will be in equilibrium with W. This W has a perpendicular distance which is equivalent to this. And taking the cos of this whole line, here this is 3a over 2, and this is 3a over 2. It is divided into half, but the whole of it is 3a. So half of this is that, and half of this is that. So it means that this distance here is going to be 3a times 3a over 2, the cos of alpha. We shall add on this. Since the whole of this is 5a, the perpendicular distance here will be this distance. That means on the 5a we shall take off this small distance. And since this is also halfway, we have 2a here, we have 2a here. The 4a being the whole of that, and the 2a being half, and even here half. So we shall add on 2w. The 2w is multiplied by the perpendicular distance, which is from here. I'll call it 5a, but I will take away from the 5a, I will take away the whole of this distance, which is going to be 2a cos of beta, minus 2a, the cos of beta. Minus 2a, the cos of beta. That is what we shall get. Since we already have these values, sine alpha, cos beta, we are going to substitute. We are going to substitute right over here. And I will have my RC. Now this is going to be 5. 5. Okay, yeah, let us first substitute here. 5A RC will be equivalent to W, we can say 3A over 2 W times my cos of alpha is 3 over 5. I will open these brackets. So I'll add 2W times 5A minus 2W times this distance here, which is our 2A cos of beta. But we know the cos of beta times 2A times the cos of beta. The cos of beta is still 4 over 5. Our interest is to get RC, so we can quickly compute this. I will eliminate A. A is common. I will eliminate it now. And I will have my 5 RC being equal to 9 out of 10W, 3 times 3, plus 10W minus 2 times 2 times 4 is going to be 16. W out of 5. When you compute that, we shall get, let me put in by 10 throughout. My 5 RC will be equal to 9 plus 10. If we take the LCM, here we shall have 100. 100 minus, by 10, this will be 32. All into W over 10. I have taken 10 as the LCM, so it goes here once. That's why we say with a 9. It goes here 10 times. That's why we get 100. And it goes here 2 times. That's why we get 32. So when we subtract from 109, we take away 32. I expect the candidates to be trying to do that subtraction. Of course, for purposes of showing that we are working through, 109 minus 32 will give us 77. 77. So I will continue and put it here that I get 77W over 10, implying that I can finally say that RC will be 77W out of 50. It is 77 out of 10 times 1 out of 5. We are dividing, which gives us 77W out of 50. That is the value of the reaction at point C. Now, after getting that reaction, we shall resolve vertically. Resolving vertically, if we resolve vertically on this very diagram, our upward forces, that is RA plus RC, in equilibrium should be equal to W plus 2W. Should be equal to W plus 2W. And of course, we already have the value of RC. Our intention is to get RA. My RA is 3W minus now 77W out of 50. Because we have it. If we make RA the subject, we take away RC from the other side. This is going to give me 150 minus 77 all into W divided by 50. If we subtract 77 from 150, we should be able to get 80. We should be able to get our RA as 80 minus 3, that is 73. That is 83. 83W out of 50. 83, this is, should be 73. 73W out of 50. That is our RA. And if you simplify it in decimal places, it should be able to give you 1 point something. Let us again check with our calculator that 73 divided by 50, will give us approximately, I can say RA is actually 1.46 W. I could also get RC here. Our RC is 77 divided by 50, and this is 1.54 W. For all of you that tried out this work, you can give yourselves marks. I did not score the working, but I believe you are checking your answers. I want us to proceed without wasting time, and now we look at the separation. When we separate the rods, then we should be able to advance towards answering the first part. Since you worked through this number, you are verifying. If you got it wrong, you are making corrections. I will separate the rods now, and I will rub off and draw a new diagram. Remember we said that when you separate the rods, it is important to use the rod that is less crowded, the one with fewer forces acting. So we are going to separate our rods. I assume that we have these values already in our mind. When I separate the rods, I will draw my diagram like this, and I will choose that this point of intersection was B. If this X goes that side and my Y goes this side, they should be equal and opposite. I have a Y here and I have an X here. This point is A, and now you will allow me to put the actual values we have got. Our reaction at point A is 1.46 W. You could still put your 73 out of 50, and our reaction here is 1.54 W. We could still put 77 out of. This rod was 3A, so if I put the weight, which was W, this would be 3A half, and this would be 3A half. 3A over 2, I call it 3A half. These distances. When I got to there is a force here we call it F, and there is a force here we call it F. We shall maintain those forces. When I come to this rod, it had a weight which was twice W, and the rod length was 4, so this is still 2A, and this is 2A. The diagram is not drawn to scale. Maybe I could readjust this to be near there. So do not say that this length appears to be longer than the other one. How come you're saying they are all? The weight acts halfway in equilibrium. Now we have a diagram over there, and what is our interest? Our interest now is to find X and Y. We shall take the less crowded rod. They are all equally the same, but we shall use AB. Considering equilibrium of AB, if we consider equilibrium of rod AB, we shall have, first of all, horizontally. I will use that to refer to resolving horizontally. Resolving horizontally, my X is expected to be equal to F. And I will call that equation A. My X is equal to F, and we have not yet got F. Vertically, resolving vertically, if I call it that, it implies that I have my RA, whose value we know, 1.46, will be equal to the value of 1.46 W. Will be equal to the value of W, which is this weight, plus the value of Y, because Y is going down. And this will allow us to get the value of Y. This is equation B, but I will solve it straight away. Solving B gives us that Y is 1.46 minus 1 into W, which implies that our value of Y is 0.46 W. If you got your Y as 0.46, you can qualify it right. Now we are going to proceed to look for X. To find X implies that we need to find the value of F. And if we need to find the value of F, we can choose to take moments here, we can choose to take moments here. So either way, if we find x, we have found f. If we find f, we have found x. I will rub off this side. We'll rub off this side. And we are considering rod AB. We are considering rod AB. The teacher is Teacher Kakuru. I want to remind you. And if we take resolution at A, we are taking moments. Taking moments at A. A is right over here. If I take moments here, W will be clockwise, Y will be clockwise, and only X will be anti-clockwise. The most important thing, my dear learners, here is knowing the perpendicular distance from the point of action of the force to the point of reference. Now, Y, the perpendicular distance of W, we already have it. So if I begin with the clockwise moments will give me W times the perpendicular distance, which is going to be 3A over 2, the cos of alpha, this angle we call it alpha, will maintain that, plus y. Y, we know the values, we shall be putting them there, times the perpendicular distance. Y is acting perpendicular. A corresponds to this point here. So the perpendicular distance of y is the whole of this, which I will call 3A, the whole of this distance, halfway. So if we take the cos of alpha, it is going to be 3A cos of alpha. So y will be multiplied by 3A cos of alpha, because it is the whole distance. And if we take moments, if we take anti-clockwise moments, we have only x. And since x is acting here, its perpendicular distance is the whole of this, because this point is in line with the action of with point A. So we shall have 3A, the sine of alpha. This will be x multiplied by 3A, the sine of alpha. If I call this equation C and this one D, we can say that in equilibrium, our clockwise should be equal to anti-clockwise. In other words, C should be equal to D. And therefore, we can go ahead and work through. Our 3A x, the sine of alpha, will be equal to 3A over 2 W, the cos of alpha, plus, I will now put in my value of y because I have it, 0.46 W times 3A, the cos of alpha. I will divide. In mathematics, it is important to keep putting these connecting statements. I will divide by cos of alpha, but at the same time, I will eliminate the 3A, because 3A is common everywhere. I will eliminate the 3A, divide by cos of alpha, so I will have my x times the tan of alpha. I'm dividing inherently by cos of alpha, so sine over cos will give me tan. I have stayed with a half here, given that the 3A has gone away, times W. So this is a half W, or a half times W, because the cos will disappear, giving us 1, plus my 0.46 times 3, no, the 3A disappeared, so we have 0.46 W. My interest is to get x, but tan of alpha, we had got it. But tan of alpha, we had got it as 4 out of 3. In case you have forgotten, this was alpha. We had a right angle here, so tan is opposite over adjacent. So it was 4 over 3. I will substitute it here, and my x times 4 over 3 will give me, if I add this is 0.5 plus 0.46, that is 0.96. 0.96 W, and I want x, so I can proceed from here and say my x will be equal to 3 cross multiplied here times 0.96 W all divided by 4. This implies that the value of x is going to be, you can reach for your calculator and get 3 times 0.96 divided by 4. 3 times 0.96 divided by 4. We will get our x as 0.72. If you got that value right, you are correct. Before I proceed, I can say, hence, since x is equal to f, we can say all of them are equal to this. X is equal to f. Remember, resolving horizontally, and therefore we have this value here. Yeah, the question is a little longer, and that is why I chose to do this very number compared to number 2. We have got the value of f, and this value of f is supposed to lead us to find the coefficient of friction that we have called mu. I will once again rub off. And after rubbing off, I can hold on for a while for those who are copying, but you are ideally supposed to be cross-checking and seeing, yeah. You know, when you do a number and you get it right, you're always proud to actually learn that you got the correct values. That's why this time round, I had to work through one of the numbers I left behind. I assume that you are way done with the value of x. Now, I want us to look at A. I want us to look at a point A. We want to find the value of mu. I will leave the diagram over there and simply remove this space. Let me keep the diagram in view. At point A, for the force at A to be maximum, at maximum force, which I will call F max, it will be equivalent to the coefficient of friction which we are looking for times the normal reaction at that point. Remember, we know the value of RA. We have it in the record. And we now want to get this expression. So this implies that since we have RA as 1.454 W, it implies that our F max at A is going to be equal to mu times 1.54. I can call this equation E. And we will also look at this force. Remember, these two forces are equal. We will also look at the force over there, and then we shall be able to equate our expressions. Since this F is equal to the force there, then we can say that since our F at maximum, our F at A max, since F max, that is at A, is equal to this value, it should be equal to FC. It should also be equal to FC. And fortunately, we have the value of F already. So those two are supposed to be equal to FC if the rod is about slip. You can say when the rod is about slip. Now, this is the condition that takes us to discovering the value of mu. So it means Because the question was saying, determine the value of mu. They are saying that if the coefficient of friction at each point of contact is mu, and one rod is about slip, so we shall consider rod FC. We shall consider this rod to be about slip, and then we shall therefore say the value here. The value here was 1.46. RA was 1.46, sorry. If I use a wrong value, we shall not be able to get the correct answer. The reaction at A was 1.46. So if the rod is about slip, it implies that the maximum force at A, it implies that the force F will be equal to mu RA, and we already got our mu RA as this, and we have the value of F here as 0.72. So our 0.72 will be equal to the mu times the normal reaction, which is 1.46. And therefore, our coefficient of friction should be 0.72 divided by 1.46, which we can compute again to get our answer, which you can compute to get our answer as 0.72 divided by 1.46. This gives us, we record our answer to 3 decimal places. This gives us our mu as 0.493. So we can therefore say, therefore, the value of mu will be 0.493. Again, if you got that correct, of course you should, what do they normally say? You should congratulate yourself. That fully brings us to the solution of part A. It brings us fully to the solution of part A. Now we can go ahead to look for the magnitude of the reaction at the junction B. We already know that the magnitude of the reaction here depends on X and Y. Magnitude of the reaction at A and B at B depends on X and Y. On X and Y. So we pick these values. Remember, we got these values. We got our X as, what was our value of X? Our value of X, our value of Y was 0.46. W, and our value of X, I want to cross check, was 0.72. Therefore, using a sketch diagram, we can choose to use that we have these two forces, Y and X. Mathematically, the correct vector diagram requires you to have the resultant coming from the intersection. That means we say you complete a parallelogram of forces. Complete a parallelogram of forces and have the resultant acting along here, meaning that the Y shifts here. That X followed by Y should give you that. Therefore, our resultant is obtained from this expression. We square and take the square root. That means we have 0.72 squared plus 0.46 squared, all subjected to W squared because they all had W, and then we take the square root. And when we take the square root, our answer will be W times. If we take the square root of the square of that, we shall have approximately 0 times 0.854, which implies that our resultant R is 0.854 W. But usually, because these are forces, force is a vector quantity, we must specify the direction. If we call this direction alpha, it is important that we get the value of alpha. Now I can comfortably remove this and finalize our working by saying that using for the direction, we use the direction is alpha, so we take the tan. The tan of alpha will be the opposite, which is the y over the adjacent, implying that alpha is the arctan over y, which is 0.46 over x, which is that, and therefore the value of alpha, if you use your calculator, should give you approximately 32.6 degrees. And since they asked you to determine the magnitude and the direction, we can conclude and say the magnitude of the reaction at B is what we have got over there, 0.854 W at 32.6 degrees from the x component or from the horizontal component. We conclude our solution with those values. If this number comes, definitely it qualifies to be in section B, and it carries full marks. It carries full marks, that is 12 marks, because you do 5 numbers and each number takes 12 marks. For the next number, I will request my producer to go to question number 2 and the homework. And my dear students, I will simply give you the answers for that number so that we can look at yet another number. Can we? Yeah. Question number 2, I am simply giving you the answers so that you cross-check. If you actually got the answers right. For number 2, they wanted you to find the reactions. For number 2, I'm giving you the answers so that I remove the doubt from you thinking that you actually did not get the answers right. They are asking you to find the reaction at B and reaction at C. The reaction at B and the reaction at C, I will summarize them. That was part 1. The reaction at A at C is actually equal to the reaction at B in this number and should have given you 39.2 newtons. Remember our value of G in mathematics, applied math, is 9.8. It should not be mistaken with the value of G in physics, which we use as 9.81. In mathematics, should be that. So the first part should have given you that same answer. And the second part of the tension, when you put in the tension, basically, for purposes of showing you, you should have had, after separating a diagram of this nature, this is T-Rex, this is Y, this is your tension, you have a force here, maybe F, you have a reaction here. If I took one of the rods, say B, A. The rods were jointed at A. So the tension, which is part 2, I'll simply, again, give you the answer. The tension, you should have got the tension as 19.6. If you got the tension as 19.6, then you also got that right. You nailed it. You got it right. Then the last part is the magnitude and direction. So you follow exactly what we have just finished doing. get the value of x, here get the value of y, and use those two values to get the resultant. And the resultant here again was supposed to be the magnitude of the resultant at A, if I call it at A, was supposed to give you the same value of 19.6. This was a very unique number, giving you answers that are the same everywhere. And of course, if I call the direction theta, it implies that that direction you should have got 30 degrees. You should have got 30 degrees. You can now confirm that you understood the lesson last time, and in case you did not, I am sure that you can still be able to try out. I will ask the producer to take us to today's additional questions. And I will ask you, my dear students, to make sure that you capture these questions. Scroll down. I'm not seeing number 1. No, scroll up, okay. I want to see the very first number. Apparently, the students are seeing, yes, right there. Make sure that number 1 is clearly seen, the whole of it. Students, I want to request you, as we normally do, in the interest of time, to take a picture of that question. And we shall give a lapse of less than a minute for you to have taken a picture. And I will tell the producer to scroll to expose the next 2 numbers. Scroll until number 1 disappears. And the students, I have put the answers in brackets right over there that I expect you to get. Scroll up so that we can see, so that number 1 disappears fully and we are only seeing number 2. Scroll up again. Up. Scroll up. Yes, take a picture of number 2. Take a picture of number 2 and number 3. You could take that at a go. Scroll up a bit. Yes, down a bit. No, down. No. I want them to take number 2 and 3. It is possible for it to be seen. Yes. Take that picture. Thank you. Students, take that picture. You can now go to the last number. There is another number, number 4. There is another number, number 4. My producer. Yes. You can take number 3 and number 4. It doesn't matter. Even number 2, it is good that he's trying to put all of them on the same screen. Because I have told you at the start that today will bring us the end of this topic. There are several questions, but they require the same knowledge. You'll keep on rotating around the same reasoning. So we are going to work through question 1. My producer, we are going to work through question 1, but my dear students, before you go back to question 1, I wanted to emphasize that statement in the footer, the footnote. It's something I put in the footnote for the students. In the footnote, yes, I have said that practice makes perfect and hard work breaks no bone. I want to remind you that don't get tired of practicing. With mathematics, there is no shortcut. No one should lie you. Don't get tired of practicing. Don't get tired of practicing. The answers you see after each number, they are in brackets. And if there are no answers in brackets, it means the number is a proof number where you are expected to get that particular expression. Thank you. My producer, can we go to question 1? Can we go to question 1? Can we go to question 1 as we move towards the end of our number? Yes, question 1 is right over there. Question 1 is right over there, my dear students. And they are asking us, question 1 is right over there. Actually, I expect that all of you by now, I want to use this, all of you by now that have seriously followed this lesson right from last Monday up to today should have capacity to find those answers correctly as required. In the interest of finalizing today's lesson, we have A, we have C, and they are telling us that there are 2 uniform rods, AB, they are jointing at B, and they have equal length. They have equal length. Those are important points. They are smoothly joined together at B. And they are saying end A is freely hinged to a rough horizontal surface. There is a rough horizontal surface means there is friction. There is friction. And then if we are to indicate the forces acting, call this reaction RC, call this RA. They are telling us, they are indicating the weights, 2W over here and W over here. And they are telling us that AB and BC have the same length. So if we choose to make sure that we denote this length, I would always advise that when they give you the same length, it is better to put a multiple of that length. We can say it is 2L. So it is LL, LL. So we are letting the length AB be equal to BC and be equal to 2L. That implies that the weight acts halfway of the length. We have L below and L the other side. Now we are going to look at to resolve and then vertically and horizontally. If we consider resolving vertically, we shall have that RA, that's the reaction at A, plus the reaction at C. We have the forces here, which I should not forget. We can still use F to represent these forces, but we are interested so much on the reaction here. Let me call it FA. So much here. So in equilibrium, the upward forces should be equal to 2W plus W, implying that RA plus RC is equal to 3W. We can call this equation 1. And then we are going to resolve or take moments at one point. Since I want to get, if I take moments here, I get the reaction RC. And if I get the reaction RC, it can help me to get the reaction at A. Taking moments at A, this one will be clockwise, and RC will be anti-clockwise. RC will have a total distance of 4L. So I'll have RC times 4L. It is the only anti-clockwise force. I will do it right away. Should be equal to W times. W starts from here. So the distance we are interested in is this. And if this diagram had angles, if these forces, the sides are equal, then there's something that is missing there. There should be an angle 45 degrees here and 45 degrees here. With that angle of 45 and 45, then it would imply that this would be W times this distance, which we can take as 2L, to 3L, sorry, the cos of 45. Plus this W, which is twice, times the distance here is simply going to be L cos of 45. So in equilibrium, we are going to compute that. In equilibrium, we compute that. And when we compute that, I am aware you are seeing that. When we compute that, we should be able to get. There is a missing component here. Since I had not put the angle, this would be having also the cos of 45. You can squeeze it in here. So the cos of 45 will cancel out everywhere. L cos 45, L cos 45, L cos 45, leaving us with 4 RC being equivalent to 3W plus 2W. And therefore, RC will become 5 out of 4W. That will be our RC. After getting our RC, we can go back here and get the value of our reaction at A. Substituting in 1, if we substitute in equation 1, we can get our RA as 3W minus 5 out of 4W. Therefore, our RA, upon simplifying, is 12, which will give us 7 out of 4W. Now, after getting those two values, remember the question wants us to show. It's like a proof kind of question. It wants us to get a proof. So after getting those two values, we need to find x and y. We need to find x and y, so we separate the rods. And when we separate the rods, even if I don't finish this, I am sure that you should be able to complete it. When we separate the rods, we shall have this kind of arrangement with xy, with 2w over here. We have got our RA as 7 over 4 w. We have got this, I call this FA. Even here we have the reactions. But allow me focus now on this so that we can utilize the remaining time to be able to finish this part. When we separate the rods, it is very clear that we can get y. Considering rod AB, vertically, we shall have that y plus 2w should be equal to 7 over 4w. This gives us the value of y as 7 over 4w minus 2w, which will give us y as, when you simplify that, it gives us, when you simplify that, it will give us the reaction there as minus w over 4. Since force is a magnitude or a vector quantity, we shall take y as w out of 4. When you sort of take moments when we take moments at A, we should be able to get this. Y will go this side, x will go this side, and 2w will go that side. I simply want to tell you that when we take moments there, we shall have x times the perpendicular distance, which is our 2L, the sine of 45. And that x is acting alone, and it should be equal to y. This is anti-clockwise. Clockwise will give us y, which we have w over 4 times the perpendicular distance, which is the whole of this. That will be 2L, the cos of 45, plus our 2w times the perpendicular distance, which is L cos 45. So this gives us w out of 4 times 2L times 1 out of root 2 plus 2w times L times 1 out of root 2. In equilibrium, I am not going to solve that fully, but I will say in equilibrium, our x times 2L times 1 out of root 2, that's sine 45, will be equal to WL, the 2 will reduce, over 2 root 2 plus WL over 2 root 2. When you solve this, we get x as, when you solve that, you should be able to get the value of x as 3/4 of w. So to complete that number, because they want you to show that mu is less than, we have a condition that f is less or equal to f max, which is actually equivalent to the value for no sleeping. So our f, we have it here, that 3 out of 4w will be less or equal to our f max, which is 5 out of 4, which is mu, times 5 out of 4w. The w will cancel, the 4 will cancel, 3 out of 5 will be less or equal to mu, implying that mu is actually greater or equal to 0.6 as required, or equal to 0.6 as required. They are asking you to get the vertical and horizontal components, which we already got. We have this, and we have the y, which we got much earlier. This brings me to the end of our lesson. I want to thank you so much for attending, and I want to announce that we have come to the close of Jointed Roads. I want to wish you continuous reading. Keep revising. Teacher Kakuru, Dennis, please don't forget to keep visiting my YouTube account, my YouTube channel. You will find lots of work to learn. God bless you. Gachali Mabaga.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory, ssaako ne computer lab.